Hi, today I'll present our work GeMix, Conditional GAN-Based Mixup for Improved Medical Image Augmentation. This paper addresses the challenge of data scarcity and class imbalance in medical imaging, which often limits the performance of deep learning models. To make models more robust, a common solution is data augmentation, generating new training samples from the ones we already have. One popular data augmentation strategy is Mixup, which interpolates between two images to create synthetic examples. This works well in many natural image tasks and improves generalization. However, in medicine, it is especially valuable to have augmentations that look realistic and preserve anatomical structures. This not only helps models learn from plausible variations, but also makes the generated samples more interpretable to clinicians. So the question is, how can we produce mix-up samples that improve learning while remaining medically plausible? Our solution is GeMix. The key idea is to move from pixel-level blending to label-guided generation. The pipeline has two main steps. First, we train a conditional GAN on the original dataset with one-hot labels, so the generator learns how to create realistic class-specific images. Second, we sample soft label vectors from a Dirichlet distribution and combine these with noise. Feeding them into the generator produces synthetic images that interpolate smoothly between classes. These generated images are then added to the real dataset to train classifiers. With this pipeline in place, the next step is to test its effectiveness. We evaluate GeMix on the COVID-X CT3 dataset, which contains chest computed tomography scans from three categories: COVID-19, pneumonia, and normal cases. Compared to classical mix-up and the generalization M-mix-up, which blend as many images as there are classes, GeMix consistently improves classification performance. Qualitatively, our samples seem to look more realistic than pixel-blended ones, preserving lung anatomy and avoiding ghost artifacts. In summary, GeMix offers a straightforward yet effective way to rethink mix-up. By shifting from pixel-level blending to label-guided generation, we obtain synthetic images that are both realistic and useful for training, leading to stronger classifiers. Our current work is limited to CT scans at relatively low resolution, but the concept is general, and we see potential to extend it to other imaging modalities and higher quality outputs. If you think GeMix is useful for your research, scan the QR codes to access the paper and the open-source repository. Thank you.